For today's Chem 121 lab, it requires you to have a 0.5 to 0.7 gram piece of magnesium ribbon. So I'm going to take this ribbon, and we're at 0.65 now, but we need to expose the surface area by taking this steel wool and running it through it a couple times. Oops, lost my paper. To get it good and shiny, so we know we have surface area and not already oxidized magnesium. So I got a nice shiny piece. We want to get our starting mass. Let's make sure this is zeroed out. So our starting mass is 0.64. I'm going to say it's still dancing around a little bit. Give it time to settle. I'm going to say 0.646 grams because that seems to be where it lives the most. So now I need to dry out my crucible. Had to go get a set of tongs so I can handle it when it's hot. I like my Bunsen burner for the striker. Got a decent blue flame. I'm going to shut my sash some to reduce airflow as much as I can. Get that closer to the flame. And I want to make sure this crucible is good and dry. There's a little bit of residue in there, but that's just from past years of doing this experiment. It just cooks into the porcelain. You can't get it out. So if you try to scrub these clean, you're going to push your finger right through them and break them. So I'm going to do this procedure until this crucible gets nice and red hot, and then let it cool down. I'm going to lost my camera there. Like I was saying, I'll let this cool down. I'll get the mass. I'll heat it up again, let it cool down, get the mass. And I want to repeat this until my mass starts being consistent. After heating this crucible up 3 times, the mass really hasn't changed. It's been bouncing around 11.940 to 11.944. It seems to live a little more at 11.942 grams. So I've got my crucible back on the clay triangle heating. And I'm going to kind of ball. I'm going to try to ball up this magnesium. I don't want to be so tight that I create surfaces that oxygen and heat can't get to. That's going to make it longer. So I'm going to try to create kind of an open cage. And then what's going to happen is, as the heat gets to this magnesium, it's going to try to burn. When that starts to happen, I'm going to put this crucible lid back on. So right now we're just heating up. I lift it up so you can see. And I'm not going to sit here and film this entire process. I'm just going to heat it. This is the final resting place of my crucible lid. You'll see a slight gap in the back. So what's going to happen is this magnesium is going to heat up until it starts to burn. And then white smoke is going to get generated. We want to put the lid back on to stop that white smoke from coming out, because that's going to be a loss of product. So my magnesium is finally burning. We want to watch that. We don't want the smoke to come out, but I also want to kind of get it to make sure all of it burns. So I still see some magnesium on this side over here. So we're just going to cover that up a little bit on this side. Give that some air. Let that finish. So our crucible's cooled down. You can plainly see that all of our product is pretty much burned into mag oxide. We're going to do our 10 drops of water to make sure we eliminate any potential byproduct. And then we'll heat this up again. Obviously more than 10 drops, but it'll cook out. I want to make sure everything gets wet. That's quite a bit of water, but we'll live with it. So we're cooking dry. It's only taken a few seconds for it to already start caking. But I'll let that cook until it's completely dry. Then we'll get our mass after it cools down. So it looks like we're pretty dry. It's good and caked white. So I'm going to kill the burner. And we'll let that sit for a few minutes to cool down. Then we'll get the mass. All right, our crucible is dry and it's ready to get our final mass. 12.824. 25. It's a 12.825. For the second part of our experiment, you guys are going to neutralize sodium bicarbonate with hydrochloric acid. You're going to measure how much sodium chloride you made. I had to move to a new balance. The balance that I was trying to mass this glassware on did not go high enough. So the tare weight of this glassware is 118.105 grams. Now it's bouncing. So 118.107 grams. So we're going to add 0.313 grams of sodium bicarbonate to the test tube. So taking the molecular weight of the sodium bicarbonate, the amount I massed, I calculated what amount of 3 molar hydrochloric acid I should use. So what I'm going to do is shoot 1 ml in and then add dropwise until it quits fizzing. So the acid is protonating the bicarbonate, which dissociates into CO2 and water. We're going to add just a drop or two to make sure that everything is neutralized. I don't see any bubbling, so we're going to call that good. So we're going to take our test tube and we're going to dry it over an open flame. We want to kind of move it around the flame and not just hold it still. Otherwise you're going to get it bumping and it's going to shoot out like a volcano. So I kind of want to keep it moving. And we want to boil all that water out of there. See the salt starting to form on the side of the test tube. So right now I'm just drying the sides of the test tube off. Once I feel pretty sure that I'm dry, a little bit right there, I'm going to set that back in my beaker and let it cool down. Then we'll get the mass of the product, the sodium chloride you made. So I'm massing our glassware with sodium chloride. It's reading 118.383 grams. So gross minus tare equals net.